I want to work on this question here. There's there's one in your notes just like it. It's the second time I address a question like this, so you should really pay attention to it. So it says the slope of a line tangent is given by y equals, and so there's the slope that's given. Notice that the function itself is not given, just the slope. And then they say the line y equals 4 is tangent to the graph of y. So we have two things. We have the slope of the tangent line, and we have the equation of the line, of the tangent line itself. So the slope of the tangent line and the equation of the tangent line. The question says find the coordinates of the point of tangency and decide whether the function has a local max, local min, or neither at that point. So two questions. First of all, find the coordinates of the point of tangency, and then tell us if it's a local max or local min. Well, so what I have here is three different aspects that I want to show you. Those three here. And so I'll spend a few minutes looking at each one of those. Let me start with this first item here. And the first thing we realize, or we should realize, is that they told us that we have y equals 4 as the tangent line. And y equals 4 looks like the equation of a horizontal line. So the tangent line is horizontal. Again, they didn't say that it was horizontal, but by giving us that equation, then we know it's a horizontal tangent. And so the slope has to be 0. And there's the slope. We take the slope, set it equal to 0. And so x must be 7. And they wanted the coordinates, so x and y. So x is 7, and the y is, well, they told us that the y was 4. So you have a horizontal tangent line passing through the y-axis at 4. So we've answered the first question. The line is tangent at the point 7, 4. Now we want to know, well, is this a local min or a local max? And that's where the second piece will help us out. Now we usually want to try the first derivative test. And the first derivative test will tell us if something is local min, local max. But this example is used because, or I want to give you this example because it turns out the first derivative test is not very useful. And this is why. What do we usually do on first derivative tests? Well, we plot a number line, and then we use the critical value 7, and then we test a number to the left, a number to the right, and we would plug it into the first derivative. But what do you notice here as part of the problem, trying to plug into the first derivative? Well, you are going to be able to plug in an x value, but you won't be able to plug in a y. And see, in the denominator we have 2 times y. But I don't know what the y value is for 6, and I don't know what the y value is for 8. I can only plug in 8 or 6, but not its y value. And because they did not give us the original function anywhere here, there's no way to figure out the y's for these two. And so the first derivative test just will not work in this case. Okay? This is important. It will not work. So then, if the first derivative won't do it for you, then we try the second derivative. Let me minimize these, move them aside. So what is the second derivative test? Well, first of all, we need to take the second derivative. And so there's the first derivative. It's a quotient. We are going to try the quotient rule and double check my work. The bottom times the derivative of the top minus the top times the derivative of the bottom. Now notice the bottom is 2y, so when you take the derivative, you do it implicitly. The derivative of 2y is 2 dy dx, or 2y prime. and then everything divided by quantity squared, or the bottom squared. And if I simplify, I can't really simplify too much, but this is me trying to simplify the expression. Now, we have to replace y prime. Y prime is equal to x minus 7 over 2y, and y prime, it was given to us, right? So I'm just plugging back in y prime. And so there's my second derivative. And as opposed to the first derivative test, let me talk about the first derivative test again. On the first derivative test, you plug in a number to the left and a number to the right of the critical value. Second derivative test, you plug in the critical value itself. You don't try numbers left and right, you just plug in the critical value. So we're going to plug in 7, 4. But one thing I realize is that if I plug in 7, 4, this y prime term, which is x minus 7 over 2y, that's just going to go to 0, isn't it? Why would it go to 0? Because we said at 7, 4, you had a horizontal tangent, and so the slope has to be 0. But if you don't believe it, go ahead and plug in 7 and 4. And basically what I'm saying is, look, everything here cancels out to a 0. And so my second derivative boils down to 2y over 4y squared, which is 1 over 2y squared. And we're going to evaluate it at 7, 4. So a much simpler expression. Plug in 7, 4. There's actually no x's anymore, so I just plug in the 4 that's here at the bottom. And so we get that the second derivative is 1 over 32. And what does that tell you? The second derivative is 1 over 32. The number itself doesn't really matter. What matters is that it's a positive number, greater than 0, positive. So if the second derivative is positive, here's my conclusion. Y is concave up, right? Second derivative tells you concavity. And if y is concave up, and remember, 7, 4 was a critical value because from way up here, down here, the derivative was 0 at that point. So 7, 4 is a critical value. You have a horizontal tangent, and it's concave up. So the only conclusion is that you have a local minimum. And that answers the second part of the question. The function has a local minimum at that point because of the second derivative test. And it's very important that you can see the difference between the first derivative and the second derivative, and why the first derivative does not work for this problem. And so I'm going to leave these two side by side. And this was the first piece that just told us that the x-coordinate was 7 because we had to take y prime and set it equal to 0. Okay? Spend some time looking at it, and hopefully if you see something similar like this, say on a test, you know what to do.